Alright, Unit 2, last and final unit. So, this form right here, all it is telling you is to take those two polynomials, f and g, and add them. When you add polynomials, all you have to do is combine like terms. So, for instance, on the first one, I would start with the highest exponent because I want it to be in standard form in anyways. So, the highest exponent would have to be a -1 and a -1x to the third and a 3x to the third, which when I combine those, give me 2x to the third. Ooh, so I can go ahead and eliminate b and c. Let's be smart about this. Then I will go to the squares. I've got 2x squared and 5x squared, which is 7x squared. Ooh, I can automatically eliminate a, so it's got to be d, but let's finish up. -3 minus 3 is -6x, and then you've got 4 and 7, which is +11. So D for sure is the answer. The only difference when you guys see f minus g of x, so if I was doing that, make sure you distribute. So I would take f, this isn't asking you this, but let me go ahead and just show you. So if I would take f, order does matter, and I'm subtracting g, oops, let me go ahead and move this, -3x plus 7. If I was saying to subtract, the subtraction is very similar to addition, but you've got to make sure you've got to change the sign or multiply everything behind it before you can combine like terms. So everything behind this, its sign will switch. Once you do that, you will get a different answer than when you add. So then you would combine like terms with the two. I'm not going to finish that, but if you'd like to try it, go for it. Number 2, you're finding the product. That just means that I am multiplying using my area model. I took up a lot of room for that one. It is a 2 by 2, or 2 by 3, so I've got to make sure my binomial stays on this side, my trinomial on the top. So we're going to multiply to the inside and then combine like terms. 2x squared times 3x to the third. We're going to multiply the coefficients and get 6 and add the exponents. That's that exponent rule, just like what we did earlier with the i's. 2x squared times x squared is going to be 2x to the fourth. Then you've got -10x squared, -27x to the fourth. Can't really see that, but -9x to the third and 45x. So the only like terms we have is -27x to the fourth and 2x to the fourth, which is going to give you a -25x to the fourth. Everything else is going to stay the same. And I'm going to keep it in standard form, which is order. So if I match that up, the only one that makes sense for this one would be letter C. Moving on, find the correct factored form. These are our identities. So the next two, we're using identities. This is my difference of squares. So you have your identity sheet in the back, but I've got the left side. I'm trying to find a plus b times a minus b. If I'm given a squared minus b squared, the only way to find a and b is to take the square roots. So the square root of the first term would be 7x. The square root of 10,000 would be 100. So now I'm just plugging it in. So my answer should be 7x plus 100, 7x minus 100. So that would be B. A does not work because it's got the i's in there. That would only be the answer if that was a sum of squares. Down here we have a, let me change colors so I don't get confused, sum of cubes. So you are given a cubed plus b cubed. So instead of taking the square root, we're going to take the cube root of the two terms, which is math 4 on your calculator. You should get 2x, and you should get 5. So you've got to plug that. The identity says I got to do a plus b, a squared, oops, not plus, minus a times b plus b squared. A plus b will just be 2x plus 5. A squared is 2x squared, which is, you've got to square both, which will give you 4x, minus 10x plus 25. So the only one that works for this one would give me letter A. Now, number 5, you've got to use, that's your binomial theorem. That's using Pascal's triangle, and we're only finding the 5th term. So you have the Pascal's triangle in the back, you've got to finish it, but the row for an exponent to be 7 would be 1, 7, 21, 35, 35, 21, 7, and 1. Then you go to your A, which is all my 3 x's. Luckily, we are not solving this whole thing. We are only solving the 5th term. Your y is negative 4. And I'm going to stop on the 5th row because I only have to go to the 5th term. So instead of writing this, well, actually, no, I'm not. So I'm going to make sure all my exponents are correct. So we're starting at 7, decrease 6, 5, 4, 3, 2, 1, and 0. 7, 6, 5, 4, 3, 2, 1, 0. The opposite direction. And I am using the 5th term, which is 1, 2, 3, 4, 5. So I am simplifying 35 times 3x to the 3rd power times negative 4y to the 4th. So I'm going to make sure I multiply all my exponents first, which would give me 35 times 27x to the 3rd times negative 4, oops, not negative 4, I got to raise negative 4 to the 4th power, which, make sure you put those in parentheses, would give you a positive 256y to the 4th. Multiply that straight across. If you do that correctly, your answer should be A. Alright, hopefully I have enough time to finish this up. This one, synthetic division. Synthetic division, you take the opposite of the divisor, which would give you 5. All your coefficients of your dividend, which would be 3, 10, negative 21, 61, and 4. You always bring down the first term, multiply below the line, and add above. 5 times 3 is 15. 10 plus 15 is 25. 5 times 25 is 125. Negative 21 plus 125 is 104. We're going to get some big numbers here. When I multiply those, I get 520, which then gives me 581. And then I got to multiply again, which is going to give me an even bigger number. And that gives me 2909. The last number is always your remainder. Then you have a constant. And we start working up with our x's because we're in standard form. So I'm going to look where really the only place that has 29 over 9, which we write over the divisor, is B. But it does match up if I added all of those up. Alright, almost finished. Using what we just did in number 6, number 7 should be pretty easy. We want the opposite. So if I'm writing this backwards, I'm looking for the divisor x minus 5. So I can automatically get rid of A, and I can already automatically get rid of C. And they've already done the synthetic division for me. This is going to be my remainder constant, x to the 1, x to the 2nd. So the only one, B doesn't have 700 as my remainder. So the only one that works here is D. Yeah, I'm tired. All right, function composition. This is how we verified the inverses on our last test, but it should be kind of a reminder. So I'm starting with G. And then I'm going to plug in the function f of x, which is 2x minus 8, into G. So I like to start. So I'm going to say 4, oops, I got an x, so I'm putting parentheses, squared, minus 5, another x, so parentheses, plus 1. So that's my G function, which I'm starting with. I'm then plugging in f to anywhere I had x. So that's 2x minus 8 and 2x minus 8. Now, before you multiply, because exponents come first, you would not multiply by 4 and distribute it. You've got to do the box. This is the same thing as saying 2x minus 8 times 2x minus 8, which is 4x squared minus 16x minus 16x plus 64. Now that you've done that, now you can multiply all of that you got, which combined like terms will give me minus 32x plus 64. You can now multiply that all by 4. Here, with this 5 times negative 8, we don't have to actually worry about doing the box. You can go ahead and multiply, which will give you minus 10x plus 40 plus that little 1 at the end. When I distribute the 4, which is big numbers, you end up getting, I'm going to write it in a different color down here, 16x squared minus 128x plus 256x minus 10x plus 40 plus 1. So 16x is by itself, it's the only x squared. Ooh, so I can go ahead and eliminate b and d. Then I'm going to work with my x's. Negative 128x and negative 10x is negative 138x. Oh, so that leaves me with only C as my answer. Alright, last one because I'm running out of time. I only got 15 minutes, so sorry if I'm going fast, but you can always pause and go back. So you're finding the inverse. Those steps. First step, replace f of x with y. Since it's the inverse, then we're going to be switching x and y. Nothing else changes. All you're doing is changing their position. Now I want to solve for that new y. So I can't take the square root yet because I got this 5 out front. He's not being squared, so I can't take the square root to undo the square because he's in my way. So I'm going to go ahead and get rid of that 5 that's there. Which leaves me with, I'm running out of room, x over 5 is equal to y minus 3 squared. Now I can get rid of that square because I got everything else out of my way. This leaves me with the square root of x over 5. These undo each other, leaving me with y minus 3. So I've almost solved for that new y. The last and final step would be add 3 on the both sides. Since 3 wasn't under the radical, he's just got to hang out on the end, giving me f inverse 1 of x, which is your inverse notation, x over 5 plus 3 at the end. I'm not adding that inside the radical. You cannot do that, which gives me C. So that is it. I know that was quick. I hope that helps you guys, and I hope you actually watch these because they will really help you out. Good luck, study. Remember, send me questions on Remind, and I will answer them as quickly as possible. See you guys on final day.